Good afternoon, my dear students. Welcome to the online classes of Royal Junior College, Hailakandi. This is your physics teacher, and my name is Baharul Laskar. So, within a few minutes, I'll be starting your physics class. So, before that, I want to tell you a brief introduction about your. Just want to give you some information about your COVID-19. So, as you know, lockdown is going on in all over India and across different countries of the world. So, and it is the best way to remain at home, so as to protect ourselves from this disease. So I urge all of you to please stay at home and maintain social distancing, as which is laid down by the World Health Organization. So, as you know, this is the only possible way now which is left to us, so as to teach you by an online medium, and it is the only medium now through which we can connect to you. So I hope you'll find. I hope you'll feel better to this video lecture, and you can learn something by staying at home. So let me start my class now. So first, I will be telling you what is there in your HS second year syllabus from physics. So units are broadly divided into. First unit is electrostatics. Second unit is current electricity. And unit number 3 is magnetic effects of current and magnetism. Unit 4 is electromagnetic induction. And alternating currents. Then unit 5 is electromagnetic waves. Then unit 6 is optics. Let me erase the board first. So, before erasing, let me tell you what are the marks distribution for these different units. So, this will carry some 8 marks. That is, electrostatics will carry some 8 marks, and from current electricity, some 7 marks will be there. From magnetic effects of current and magnetism, again some 8 marks will be there. And even your in electromagnetic induction chapter, your 8 marks will be there. And from electromagnetic waves, 3 marks will be there in the exam. And from optics, some 14 marks will be there. So that's why this actually carries the highest marks. So we have to read it carefully, okay, because maximum mark is from this chapter. So let me erase the board. Then your unit 7 is dual nature of matter and radiation. After that, unit 8 is atoms and nuclei. Then unit 9 is electronic devices. And finally, unit 10 is communication system. So this is not required anymore. So actually, why I am writing all these things? Because you should have a clear idea what is there in your HS second year syllabus from physics. So, okay. Your dual nature of matter, it carries again 4 marks. Atoms and nuclei, there will be some 6 marks. And from electronic devices, again some 7 marks. And from communication system, there will be some 5 marks. So if you add all these things, then there is earlier units and the marks of earlier units and all this, then there will be total 70 marks. Okay. Now it is not required. So I basically teach you optics currently. After that, I will go to electronic devices, communication system, and electromagnetic waves. Okay, after that. Okay. First, let me start with optics. So we need to know what is called optics first. So obviously this is a branch of physics. Okay, like we know there are different branches of physics, like suppose electromagnetic waves, electromagnetism, your thermodynamics, like your mechanics, your everything, your current, electricity. These are different branches of physics. So likewise, optics is also a branch of physics that particularly deals with it's better to write like that. It is a branch of physics that deals with the nature of light, its sources, properties, and effects. So optics is that branch of science, that branch of physics that deals with the nature of light, its sources, properties, and effects. So that means we are dealing with light only. In optics, we are dealing with light only. Its nature, what are its properties, what are its sources, it means from where we will get light or not, and what are its effects, what are the effects of lights. So these are the different things we will learn in optics. So it basically deals with light. What is its nature? So you know, light is having dual nature. Sometimes it is having a particle-like nature also, and it is having also your wave-like nature. So all these things we will learn in optics. So its sources means from where it is we can get light, and what are its properties, and what are its effects. So in gist, I can say that optics deals with light. It is that branch of physics that deals with light, or it actually deals with the nature of light, its sources, properties, and effects. So after knowing that, so actually now again optics is divided into, okay, I will go to light a bit later. So again, optics is divided into, if we divide optics again, it is, if we categorize optics again, then it is divided into your physical optics, or sometimes it is also called wave optics. Again, it is divided into your ray optics or geometrical optics. So optics is again divided into physical optics or wave optics and ray optics or geometrical optics. Now what is physical optics? So earlier optics, we said, we learned that optics is the branch of physics. Now again, optics is again divided into physical optics and your geometrical optics. Now how do you define this physical optics or your ray optics? So you define your physical optics. So it is that branch of, now I will write like that, it is that branch of physical optics is that branch of optics. Now we are under optics, that's why it is that branch of optics that deals with the wave nature of light. So that branch of optics which deals with the wave nature of light, we said that it is called physical optics. So under physical optics, we will study those properties of light which are related to its wave nature. Okay, so physical optics is that branch of optics which deals with the wave nature of light. So now again, ray optics, I will categorize it again under wave optics. What particular thing we will learn, I will write it later, but let me define it first. What is your geometrical optics? So let me erase this thing. Let me start from here. So now I am defining your geometrical optics or ray optics. So it is the branch of optics which deals with those properties of light so it is a branch of optics that deals with those properties of light which can be easily described with straight line or plane geometry. So the branch of optics, because geometrical optics or ray optics is another branch of optics, so it is that branch of optics which deals with those properties of light in which can be easily described with straight line or plane geometry. Okay, those properties which can be either described with straight line or plane geometry, we deal with we study those properties of light only in that particular branch of optics. So for example, specifically what we study here is suppose rectilinear propagation of light. These are the different things we study here. Suppose rectilinear propagation of light. What is the rectilinear propagation of light? So it is a property of light which states that light travels in a straight line. So these are the different this is particular theorem, you can say that this is called rectilinear propagation of light. So, and also we study here your reflection, suppose also your refraction. So if you look carefully here, so all these things can be described with straight line or plane geometry. So either by straight line or a plane geometry, you can describe all these properties of light. So these things we study under your geometric optics. Also your dispersion. So this different property dispersion, these different properties of light we study under your geometric optics. So okay. So I missed that thing what we study in your wave optics. Definition I wrote earlier, but what are the different properties of light that we study here? So under wave optics we particularly study this thing, this wavelength of light. So particularly your interference, your diffraction, your polarization. So these are different properties of light which you will study under your wave optics. So interference, diffraction, polarization, and you have something there is there. It is there Doppler effect. So we'll study all these things under your wave optics, and we'll study all these things under your geometrical optics or ray optics. That is reflection, refraction, dispersion. Okay. Let me erase the board. Since this is the first class, so I don't want to extend it more, but let me share a few things more from optics. So as you've learned that the optics is the branch of physics that deals with the nature of light, its sources, properties and effects. So ultimately we study light here. So first we should know what is called light and what it means actually. So light, it is a form of energy. If anyone asks you what is light, then that should be your answer. It is actually a form of energy that causes the sensation of vision. So we need light to see objects. Okay, without light we cannot see object. You cannot see me, I cannot see you. Okay, I'm viewing right now everything around me, suppose this wall, board, everything, because of light only. Because light either directly reaching from the source to me, to my eye, or by after reflection from the object, light is reaching to me. That's why I am seeing that particular object. So either by directly reaching also you can see the object, or by after reflection also, when it after getting reflection from the object, when it reaches our eye, we see that particular object. So that means we need light to see objects, because in dark we cannot see anything. So, and it is actually a form of energy, and that causes the sensation of vision. Because of that we can see the things or see objects. So first thing is, it is a energy. So it is a energy. Like your different forms of energy are there, like your heat energy, like your everything, your mechanical energy. So there are different forms of energy. And the mechanical energy, we know that is potential energy, kinetic energy. So like your electrical energy. So different forms of energy are there. So gravitational energy. So like that, your light is also a form of energy, and other energy forms of energy are also there. So light is actually a form of energy. So, and we know one particular one important theorem of energy, that energy can neither be created or nor can be destroyed, but it can be transformed from one form to another. So this is called law of conservation of energy. That means light is also is not like that. The light is directly coming to us, so it must have been converted from some other form. So like from some other form, light must have converted into light energy, because energy can neither be created or nor can be destroyed, but it can be transformed from one form to another. So light also, we are seeing light. So light energy also must have converted from some another form of energy, like from suppose from heat energy it must have converted to light, or from any other form of energy it must have, or suppose electrical energy it must have converted to light, because energy can neither be created or nor you can destroy it. So we need to know about and before going to that, how we get light from different objects. So we first need to know what are the sources of light. How light is converted, how the light energy is converted from another form, we'll study later. But before that, we need to know what are the sources of light. That means from where you can get light. So this is called sources of light, because the very definition of optics says is a branch of physics that deals with the nature of light, its sources, properties and effects. So source is there. That means what are the sources of light, what are its properties, is very there in your definition. So that means the source of light means from where you can get light. So sources of light can be two things. It can be either your natural sources, or it can be your artificial source. So sources of light can be either natural sources of light, or there can be artificial source of light. That is man-made source of light. Artificial means man-made. So natural sources of light, we know what are the natural sources of light. Suppose sun and all the stellar objects. So these are the natural sources of light. Sun is also a star, we know, and all remaining stars, from those things we are actually getting light, and these are the natural sources of light. We are not creating those things, it is produced by nature. Okay, so artificial means man-made, from where humans generate light, you can say that. So like your electric bulb, these are the examples of artificial sources, which are man-made sources of light. Human use some techniques or some methods so as to produce light. So like electric bulb, like your wooden fire, like your candle fire also, or earthen lamp. And so on and so forth. So from electrical bulb also we know that we can get light. From wooden fire also, if we burn some wood also, we'll get light, we know, from the fire. And from candle fire also, we know, from candle we get light. And all these are man-made sources. And also from earthen lamp, in many of the villages people still use lamp, so from there also we can get light. So these are the different artificial sources, and these are the natural sources. So this is all about your sources of light. And in all these things, actually, in all the natural sources also, also in artificial sources, light is actually getting converted from one form to another. Suppose from heat energy to something another form. So because it is an energy we cannot create or we cannot destroy, but it actually is just converting from one form to another. So I want to say that we are getting light in different sources of in these different sources of light, but it is actually getting converted from some other form of energy. So right now I want to tell you that thing. So how the process of conversion, that is the process of conversion of energy in different sources of light. The process of conversion of energy in different sources of light. So because you need to know that thing. So it may not come in the exam, that is true, but you should know this thing, how light is actually converted in different sources. Because if anyone asks you, you should be able to answer this thing. So first thing, let me consider your natural source. Suppose your sun or any other thing. So here actually what happens in natural source like your sun, specifically in sun or in any other stellar objects. So actually light is getting converted from that thing. Your nuclear fusion reaction is there,